老师。Okay, so yeah, sorry about that. We started a little bit later today. We started at 7:05. We will continue the class we stopped at last week. And you know, in the first class is pretty much give out two bronze test examples. So give you guys an idea how the real problem looks like. So then, you know, get you guys to think about those two problems. So you know that it's really not like a program we are doing for robotics or in like a programming you learned from a language class. It's not like that. It's different. It's really wanted to get you into write a solution and find the best solution and write an efficient code. As I mentioned, if you do the competitive programming, you really need to consider how efficient your code is. You need to make sure your code is very efficient and it can solve the problems if you have a lot of data. So that's the purpose. So do you still remember the problem we had for last week? The harebells, they call it harebells, how many harebells they call it. So I get several submissions and I think almost all submissions have the same solution, the same idea. The code varied a little bit. I want to share one code sample, and I want you guys to take a look at the code. Then you can tell me if this code can be improved, or do you understand what the code is doing? So let me share that first. You guys take like 1 minute to read the code, and then tell me if this can be improved or not. Okay. So this is the code. Please take a look at that. So let's spend like 1 minute to read this code. Hi, Jesse. Can you see the code so you can see this screen? So Luca, you finished reading? Not yet. So Aaron, have you finished reading?
Yeah.
Okay, do you understand what the code is doing?
Yeah, I think so.
Can you explain it?
Okay, so the first few lines is just like reading the input. And then like you have like a for loop which like iterates for like every one of the like days you get food, and uh and then like it will so it will subtract from the number of so like add to the number of veils, and then it will if there's like more than like more bales than like one, then it will more than or equal to one, then it will minus a bale, and then it will add a bale to the total eaten, and then it will print how much has been eaten.
Okay, so Austin, did you finish reading?
Yeah.
So when you read this, you think you understand what the code is doing, right?
Yeah.
Okay. So I think, yeah, all of the submissions I got, actually, it has the same sort, and that's good. That means this may be the most efficient solution. So I like it. You go very straightforward. If you have hair bell to eat that day, then you count it. If you do not have it, you do not count it. So every time you eat hair bell, then you just deduct it from the hair bells you have, right? From the stock. So that's how you do that. That's very clear. That is very clear. So everyone did this. But if you are the judge, okay, if you are the judge, if you are the teacher, when you read this code, do you think you can improve it, or you can give me some suggestions, or you can you tell me if this code is wrong or not? Will the code do the work or not? So look, when you read this. You think it's good? Any place that we can, any room we can improve?
I think this is more.
Okay, this is what I is. So those two lines actually, for maybe some of the occasions it doesn't change at all, because that day you do not have any delivery, so it will stay the same. So you put that variable there, so it will, every time when you do the loop, you need to calculate that. Right? Okay. So yeah, do you guys agree? Do you agree? Yeah, because you say, let me show you. So line only changes here if this situation happens. Okay, so it only changes here. That means if you have like a million days, but you only have delivery in like 100,000 days. So then you have like 900,000 days. Actually, this doesn't change at all. You get into this. It doesn't change, right? Does it make sense? So that means you, every time you come in, you need to do that calculation. That's something we can improve, right? That's something we can improve. All right. So that's one thing. Okay. So nobody get to the most efficient one for this submission, but I will come to that point. But do you guys think if we can improve this part?
You could use list comprehension.
Yes. So this, let me put it this way, okay? you read the file in, you read the entire file, and then you split it, and then now you loop again. So that means you do two things, do the same thing in two steps, right? One step is a repeat of another one. It's a repeat of another one. So that means you may have something to improve. Think about that. Most of us just read how many lines we have. We just go to read those one by one. So that will be more efficient. So you do not have to do this line at all. And then you can improve that. You just see how many lines I have. I will just read that line in. I will read that line in. Okay, here you already read everything in, and then you come to process it. So that means you are doing it twice almost. Not exactly twice. Once reading everything, then now you get everything you needed to split them to process it. All right. Make sense? Does this part make sense? Okay. All right. So, all right. So let me say in say Irvin's code, because Irvin was the person who submitted the solution right after class last week. So let's take a look at this one. So see if this makes sense to you. Irvin, do you want to just go through your code, explain it, make sure everyone understands it?
Okay, so for the first line, I just like use list comprehension to convert everything into integers, and then I set n to like the first thing in nt, and then I set t to the second thing in nt, and then you create a dictionary in the fourth line, and then I used a for loop in order to like get the additional input and set it into the dictionary. And then I set two variables all set to 0 called available and 8. And then I did another for loop with range, and I did 1 and t plus 1 as the parameters. And then so basically in the for loop, I basically made it so that if the day was like, if the like I is like the day where the cow gets hay, it adds like the amount of hay that's like set in the dictionary for that day. And then after that, I also added this thing that like basically checks if like available is greater than 0, and if it is, it will add a 1 to the 8, and then it will subtract 1 from the available, and then it will print 8 after like the first days.
Yeah. So when we look at this code, I think it's very good. You really don't see that this like a line is redundant or extra. We don't need them. So looks very good. But I want to ask you guys, is this solution the most efficient one? Is the solution here? Think about that. This is the most efficient one. When you read this code, do you think it's the most efficient one or not? This is a very good solution for us at the beginners class to solve it. Okay, it's a very good solution already. But as I mentioned just a little while ago, still is not the most efficient one. The reason is that, you see, I will look through to T. I said if T is a 1 million base, so you have 1 million base. That means this loop needed to run 1 million times, right? Needed to run 1 million times. But you may only deliver 100,000 days. Only 100,000 days you made the delivery. So you see here, Urban created a dictionary here, DB, right? DB is a dictionary. That means this dictionary only have 100,000 items in it. So if you use this DB to do the loop, you only need to loop through like 100,000 times instead of 1 million. Instead of 1 million, right? So that will be much, much more efficient. Do you guys agree? If you use the DB to do the loop, but if you use DB to do the loop, then you need to have another way to calculate, right? You need to see what is the day for the delivery, and then what's the label in stock. Can it cover that gap, right? Can it cover that gap? If it does not, how many papers the car has eaten? So you need to do it in a different way now, the calculation. Do you guys understand what I said? When you want to look at the efficiency of your coding, do you get what I said, Irvin?
Yeah.
So I think you did it in that way, right? Yeah. So let's take a look at what Luke does. So Luke did it in a very good way to solve this problem. So let me do this one. Okay, Luke, can you explain your code? Okay, so Luke has one more, efficient step here. So Luke still loops through the days. Okay, he still loops through the days, but he has an efficient step here is break the loop. So if you have enough in the stock, and then that can cover to the end of the days, then you jump out. You do not need to do the loop anymore. And he did not use extra time to do the calculation. You see, he did the total delivery already when he received the data. So he gets the total. He gets the total already. So in this step, so he does not need to worry about, okay, I need to go through all the deliveries. I get the calculation there. No, so that's a very smart move here. So you already get that total number here in this step. And we will spend a lot of time, I think, in the theory, in my slides for the following weeks. Okay, I talk about these things. Now, what is the more efficient when you write your code? You do this calculation. It's called a 1. Okay, if you do loop, it will call it n. So if you do this calculation, you just take it's efficient 1. It's the most efficient way. If you do a loop, it's n. Okay, and then you do next loop, it will be n power, right? So we will discuss about that. We will spend weeks to do that. But you see, look, use this loop and finish that calculation already. So that's very efficient to do that. But he still loops through the dash from, you see, for I in range T. He still did this. Okay. So that means you still need to go to that day, even that it does not have any delivery. But he has a smart step here to break the loop. So it does not have to finish all the loops. Even, once you have enough hairballs in the starter, you stop it. You don't need to go through it anymore. So you will know how many hairballs that the cow will eat. Because the cow will not go hungry in any given day after that. Any given day after that. So that's a very smart step, but still not the most efficient one, okay? So I want you guys to go back, use Luke's smart step here to break the loop. Once that condition is satisfied, also you loop that dictionary, not this, okay? I tell you, that is a big difference there. Of course, if you just do like 1 million, it's okay. But how about if it's a trillion? If the number is a trillion this, then you need to loop a trillion times. That's not efficient. For the beginners, for the students in class at this moment, it's okay. And then a lot of students, okay, just think, okay, I'm smart, I can write code, and how smart I am. Yes, you can write that code, you can solve the problem. Not a problem. Yes, you are, but I want you to spend more time to think about that. You need to switch your mindset. You need to get into this direction. See how can we improve our code? How can we improve our code? So you get my idea, Abby and Austin? Are you both still there?
Yeah.
So
Yes.
you can hear me, right?
Yeah.
Yes.
Okay, good. So you know that we needed to, think about this. Of course, this code for the bronze contest has no problem. It can always solve the problem within the time. But once you get into gold, if you do it this way, they will trap you into it. Specifically, they will trap you into it, and your code cannot finish running in 2 seconds because they will give you a lot of data to process. So you cannot. So you need to think about it, another way to do it. Okay, makes sense? All right. So if this makes sense, I will make this your homework. You need to go back to improve your code. Now think about how can I calculate the hairballs that they call it. That's called it. Okay. So go back to do that. So now let's come back to do the theory stuff. So do the abstract stuff, and I will teach you one more thing. Okay. So when we do the competitive programming, so it is very a sport, just like the robotics. It's a brain sport, okay? It's not like a physical, so it's fun and very challenging. So you need these skills. So you really need to understand this. You can break it like a record in the world. You will be very famous if you can make some changes. Obviously. So a lot yes, improve a little bit, algorithm. Just spend the life on that. Okay. Just spend the life on that. So we need to spend the time. And then how can we improve it? So then we need to first, okay, for the beginners or for the normal programming, a person or a student must have the ability to think about a brute force solution. Okay, a brute force solution. So what is a brute force? We will talk about that. So it's a good practice of all data structures. So I will talk about a little bit on the data structure, and we will spend a lot of more time once we get into gold, silver, gold. Okay, so you need to structure your data. How do you structure your data when you create your object? When you get into Java, like a level 3, level 4, we talk about the classes. You need to create your own class. And for Python, you can create your own class. You can use the class to handle that. So the data structure, right? When you talk about that, this is a very advanced. That's very advanced, okay? So you need to know those, right? So first thing, let's talk about brute force. Okay. The brute force algorithm is, so Chloe, can you help me just read this paragraph, the first one? Thanks. Yeah, it's trying to exhaust everything. So just like what we did, so we look through every day. On that day, if the apple is eaten or not. On that day, if the apple is delivered or not. How many was delivered? So you try to exhaust it. So you look from the beginning to the end. So that's brute force. You're trying to exhaust it. So you just rely on the computer power to exhaust all the things. So, okay, this is an example. In our center, the dialog is safeguarded by code panel with digits 1, 0, 1, 2, 3, 4, 5, 6. The center director forgot the door code. In the worst case, how many tries she needs to do before she can get in? Can anyone think about this? How many tries?
How many digits is the code?
The digits is 7 digits. You say 0, 1, 2, 3, 4, 5, 6, right? Total is 7 digits. All right? Oh, you mean how many digits? Like the key code? Okay, let's say 4. Think about this. When you guys learn the mathematics, So you have 7 numbers in the pool. So every time you go into the pool to pull out one number, then put that number back into the pool, then the pool is out again. You pull times. That's a possibility. That's how many possibilities? How many tries you may need a tree. Right? Do you agree? So that's a big number. Can you guys just do the Google search? I think that's, I forgot the term. Matrix. You put a number there, and then put it back, and then put it again, put it again. Yeah, so say how many times it's a huge number. Huge number because you may pull 4 numbers the same 0, 0, 0, 0. So this is a brute force. If I ask you, so to try, and that's also how a lot of hackers trying to break your account. They try to get password. So that is also why now in the companies they want you to use like at least like 12 characters for your password, because usually if you get to that long and a computer cannot break it maybe in a month, so then the hacker cannot do that. Keep trying for a month, then that's too many tries. So they will be detected, right? So you need to exhaust all the possibilities. That's a brute force. That's a brute force. And this costs a lot of computer power to do it. A lot of computer power. Okay? Of course, we only have like a 7 number. It won't maybe just a second. And how long it takes to do it? How long will it take to do it? I will get you guys to work on that in the future. So you understand how efficient it will be. Okay? So this is just when we put it. Okay? All right. So the next one. So what is the efficiency? So the efficiency of a solution is determined by the amount of computing resources that they require to complete their task. So a common way to evaluate an algorithm is look at its time complexity. And I already mentioned it's a bigger thing in our class. This shows how the running time of the algorithm grows as the input size grows. The input size grows. Okay. So a classic problem. I already asked you guys to think about this, and Jesse, send me the code. It's at Queen Puzzles. Okay. So you need to read this problem and think about that. What is your solution? I did ask you guys to do that. And we will talk about this one a little bit. I'm not split the class today. So let me just continue to talk about this. So the first thing I wanted to get you guys into some basic stuff. Okay. So you see, this is the, okay. So what is the problem? What is it? What is the story? We talk about brute force. Okay. We talk about brute force. And this will be one of the solutions, right? Like actually 4 of the solutions. Okay. So that's what it looks like. So you put the queen there. So what we are going to do is that we put the first queen in the first row, first column. Put it in there. Then we try to do second queen, right? Where should I put it? Of course, we need to exclude those positions. We'll create right? We need to avoid that. Then we're trying to put it in the second row, but with which column? So that's what we're trying to exhaust. So of course, for the second one, you have like a 6 possibilities to put. You have 6. And then you can put it in this position. Okay. You can put it in this position, this one, and then you try to put the third one. You keep going this way, and then you find out you cannot put a queen at that position, because if you do that, it will give you a problem. You cannot get to the 8th row at all. And then it's finished. It's done, right? So that's it's brute force. You need to go from the beginning and try all the possibilities, see if it works. But before we go into it, so I want you guys to be able to. That's a communication skill you need to have. When you grow up, when you get into the government, or when you get into a company to do technical job, okay? This is a critical skill you need to have. So you want to communicate between the developers of flowchart is widely used to depict a computer programming solution. So I want you to be able to do that. If you do not show the code, then you need to be able to do this flowchart. You need to tell me what are the steps. What are the steps? So let me show you the example. So when we discuss the problem in the future, we wanted to be able to get to this level. This will help you develop a skill for your future. Okay, this is the flow chart. So you see, you will start, then you will do process. Okay, and this use a diamond. Okay, use a diamond. To start and end, you use this kind of shape. Okay, this shape is a process. It is a process. So you wanted to talk about how will you proceed? How will you do the program? Okay, so you see this flow chart, and then let me give you the basics. So flow line, you have the terminations, you have the input, output, you have the processing, and then that's the shape. Okay, when you do your flow chart, you need to make sure that you have those. That's how you communicate with other people. Even when you communicate with your boss, if you have the flow chart, it will be very clear. It will be very clear. Okay, so these are the basic elements, and basic elements of a flow chart. And then let me just show you one example. And then this is the loop. So when this and then you need to do decision. And then this is the right. And then you come back with this is how you depict the loops. Okay, you depict the loops. And then it goes to the end. So what was it that to be able to do flow chart when we discuss complicated problem in the future? We come to the class, we discuss the problem, we see how should we solve it. Okay. So let me come to one of the that. So let's start it. Start from row 1 and column 1. Okay. So then add the position of the queen to the list. Okay. So that means at queens, you have the 8 position. The first position will be 1, 1. Okay, that means row 1, column 1. So 1, 1, you add to that list. That list means if the element is a tuple, right? It's a couple. Couple you have row, have the column in it. Add it to the list, and then you position the next queen in the next row from column 1. Right? Use that from second row, then the column 1. Then now you need to make a decision. Is this valid? If that position is valid, you need to do that decision. If it's not, come back, okay, to the next column. Check if it's valid or not. If not, you need to come back again. But if it is valid, then what do? You will check if this is a solution or not. If it's not a solution, you come back, you need to do this, do the next group. You keep doing groups, okay, coming back from that. So you do the next row, keep going. And then if it's a solution, that means you finish all 8 rows. And then each row you have a position. Then you can add that solution to the list. You create a list, you add that solution to that list. So then you back all the options. If not, you will continue. Come back. That this is how loops inside it. How many loops inside it. So I'm not sure if you guys understand the flow chart, the solution when the brute force solution to the 8 queens. So this talk about a clear brute force solution. You try to exhaust all the possibilities, all the options. So you from start here, and then you do row 1, column 1, and then find the first solution. And if it's not exhausted, coming back. So then the next one, the bigger iteration is that put the first queen in the row 1, column 2, right? And then start over again doing this. So do it again, until you finish the queen from row 1, column 8. And then you don't have any more solution. That will be your total solution list. Okay. All right. So that's a flow chart. Any question on this? Because I needed to get you guys to be able to communicate to me in using flow chart. You can write code, yes, but for very complex code, the judge will not look at your code at all. The judge will just run your code using the test. If you opted to what you do or not. In the class, me and you communicate and apply the or is it valid or not? So it's critical. Okay, so let me give you guys an exercise to do. So when we learn color, we know that red, green, and blue are basic colors. The respective value can be 0 to 255, right? Respectively. The red color can be 0, can be 1, can be 2, right? Can you write an algorithm in your preferred programming language that can print out all possible color combinations. The printout should look like this. Color 1, color 2, color 3. Okay? Just write a program. Just write a program. So you can print out all the colors. All the colors. This actually is a brute force. You need to find all the possibilities, all the combination possibilities. Can you guys go ahead and do that using this like a yeah, you just need to print out color 1, okay, color 2, color 3. Go. There will be millions of colors, right? Millions of colors. So I just want you guys to write the possibilities. Write it down. It should be very straightforward. Just go ahead and write the code, and then you think about that. Then you just tell me your solution. But I want you to write the code for because we are doing the contest. Contest needs you to write the code. So I want you to be able to quickly write the code because there's no any language difficulties here. No language difficulties here for us to write the code. Very straightforward. And if you finished, and you can put your code in the chat, we can discuss that. Finished? Okay, let me take a look at it. Yeah. Yes. So you but just please, make sure you print out this color 1 and the parentheses, those numbers. Okay. Your solution, how you do that, and then Austin and Evan, if you finished, you can raise your hand here in Zoom, so I know that. But I give you guys several minutes, and then I will ask Jesse to share and explain his code. And then we can think about what is the most efficient way. Yes, you finished? You wanted to share? You can share your screen. I can stop sharing. What? Okay, you can share your screen, Jesse. Oh, are you in Zoom? You're not, right? Okay, you're not in Zoom. Can you get on Zoom? Yeah, mute your microphone and the speaker. Get on Zoom, so you can share your code. So, Holosh, do you see Jesse in Zoom or not? Okay, do you? Okay, Austin, you have. Okay, can you explain your code, Jesse? It's very straightforward as what Jesse put here. You actually have 3 nested loops, right? And each column it has a value from 0 to 255. Okay, they just nested it 3 times, and then you output those values, those combinations. So the altest loop from 0 to 255. This treat that as red, okay? And then blue, okay? Blue is from 0 to 255. You also nested in the red color. And then you have the green, right? The green, or RGB. So the second one is green, the third one is blue. So you also nested that so that you see you have 3 levels of nested colors, and then you combine them together and print it out. So very straightforward. But when you think about this, okay, so you say Jesse is processing it and it has not finished processing yet. You say how long does it take, right? It's a very big number. Though you say you only have like 255 values for each every column. But you see how long does it take to finish processing? Minutes, right? The Jesse's computer is still processing that. So that's a big number. So think about this. And let's say we have like 1 billion possibilities. Actually, so 255 times 255 times 255. What is that number? Go use the calculation to get accurate to do it. 255 times 255 times 255. That is you're going to get. Actually, it's 256. 256 times 256 is 256. Right? So that will be the total iterations you run it. So that's the combinations for the possible colors you have. So it's not a big number, but still it takes time to process it. Thank you, Jesse. Very good. Very wonderful. And so, Austin, you raised your hand, and you have anything for me, Austin?
No, I just finished.
You finished? Do you want to share your code?
No.
Okay. So, do you guys get this? Do you guys get that? Okay. You get it. All right. So then you say, whatever I ask you guys to do is that you have the 7 numbers. You just the key code is 4. How can you write the code to get the key code? How should you write a program to do that? Go ahead, write that code. Say what will be the key code, and then how many loops how many iterations you have to go to get that number. So you have the number from 0 to 6, right? And then the key code is 4. So you see what is the possibilities there. So right now for the color, we only have 3 nested loops. For the key code, because we have 4 numbers, so you need to have 4 nested loops. Each loop will loop from 0 to 6. So you need to use a 4i in range 7, right? 4i in range 7. You get it 4 times, nested them together, and then print out the number, put them together, to create that number. Tell me how many. How many possibilities? Yeah, really not that many, right? Really not that many. Not that many, because every time you only have like 6 iterations. 6 days times 6 times 6, then times 6. Oh, 7, yeah, 7 times 7 times 7 times 7. Yeah, so not a big number there, right? Yeah. Okay, but let me ask you guys, does that make sense? Does this make sense? How you build the algorithm to solve this problem, this kind of problem? Does it make sense? So this is called brute force. You are trying to exhaust all the possibilities. So you are using loop, nested loop. Usually in USACO, they do not want you to nest the loops in too many layers. They don't want you to, because that will significantly increase the processing time significantly. Okay, I think that's what I have. reviewed the code with you guys for the last problem. I'm not giving you a problem for 1 or 2 weeks. And then I will give you another problem, a simple one. And I may ask you doing a hard one for bronze. Ask you doing a hard one, then you will think, okay, bronze is really not that easy. It's not that easy. Okay, so we reviewed this problem and ask you guys go back to use that dictionary to look and combine the smart step that look ahead. Okay, so you can break the loop. If you have enough paper in stock, break it. So that will be the most efficient way to solve the problem. So go back, write the code, submit it to me. We'll put that in our classroom. And then also we talk about what is the brute force. And the most important thing is that I teach you guys the flow chart. I really want you guys come back to think about how you should do your flow chart to communicate with other developers or with your team. Because if you don't have a flow chart, you just talk about it, maybe you will lose the team members. They cannot catch it. But you have a flow chart like this, they will know every step you are going to take. So it is very clear to your team member or to your manager, to your teacher. So how you solve this problem? How you solve this problem? Okay, very good. Any question? Any question? So Austin and Irvin, do you have any question?
No, but I have like a code for the like colors combinations one.
Do you want to share it?
Sure.
Yeah. So can you share it? Let me see.
So for my code, I did list comprehension.
Uh-huh. Yeah.
And then like for every color in the list, I just print it.
Yeah, that's also good. Also for the class, you need to think about that because USACO also tests you. So your file size cannot be too big. That means you cannot have too many codes. So the most efficient code, it's not only says that you process it efficiently, it also say your code is most concise. So most simple code. So this comprehension in Python is widely used. So that's very good. So you say you only need like how many lines of code? 4 lines of code. 4 lines of code. So then it can get the work done. Okay. Thank you, Evan. Very good. Okay, any other question from the class here in the room? Okay, if not, we will just conclude this class and we will see you next week. Next week is not July 7th, right? It's not week. Okay, all right, so that's what I have. And thank you all, and you guys have a nice evening. And let me know if you have any question. Please go back to your code. And actually, I only get, let me see, I only get 4 submissions in the classroom for problem 2. I hope I can get all the submissions from you for this improved coding on the hairballs, okay? On the hairball problem. Okay, good night.